Number 21, solve for x. Round your final answer to one decimal place, but do not round until the final step. Alrighty, so we need to get rid of these logarithms so that we can solve for x. In order to do that, we're going to have to do a bye-bye logs problem or a burn the logs problem. So we want, on this side, we just want one logarithm, and on this side, we just want one logarithm. So let's see how we can do that. Using the properties of logs, when you subtract logarithms, you divide the not the exponents, the arguments. That's called the quotient property of logarithms. So this log base 5 of x minus log base 5 of 2 becomes log base 5 of x divided by 2. All right. On this side, this 1 is not a logarithm at the moment, but we can turn it into a logarithm if we remember that logarithms are exponents. We need to create a logarithm with an exponent of 1. Basically, log base 5, because this other one has a base of 5, we need them to have the same base, of 5 is equal to 1 because 5 to the 5th power is equal to 1. Like if I were to evaluate this logarithm, it'd be equal to 1, 5 to the 1st power, right? So minus log base 5 of x plus 2. So I can go ahead and condense these logarithms in the exact same way I condensed the other logarithm. Log base 5 of x minus 2 on the left, that remains unchanged, but this is going to condense with the quotient property, log base 5 of 5 divided by x plus 2. Then we are going to burn our logs, bye-bye logs, and we have x over 2 equals 5 over x plus 2. Now, when you, just like one of those previous problems, if you get a fraction equal to a fraction, you're going to cross multiply. So on the left side, we do x times x plus 2. On the right side, we're going to do 2 times 5. If we simplify this out, that becomes x squared plus 2x equals 10. Then we solve this quadratic equation by moving everything to one side, set it equal to 0. X squared plus 2x minus 10 equals 0. And then we're going to factor this, okay? So the factored form, we need two numbers that multiply together to make negative 10 and add to make 2x. Oh, actually, no, wait, because there are no numbers that multiply to make negative 10 and add to 2x. The only possibilities are 1 and 10. That doesn't work. And 2 and 5. That doesn't work. So actually, we're actually back here at this step. We have to complete the square. So what we're going to do is we're going to add a value to both sides. We did this on a previous problem. You complete the square by adding half of the b value squared to both sides. The b value here is the one attached to the x. So half of 2 is 1, and 1 squared is 1. So we're going to add 1 to both sides. X squared plus 2x plus 1 equals 11. 10 plus 1, right? And then this is going to factor into a binomial squared. X plus 1 squared is equal to x plus 2x plus 1. And we're going to go ahead and keep this 11 the same. Now we get to the x by taking the square root of both sides. So x plus 1 is equal to the positive and negative square root of 11. And then we get the x by itself by subtracting 1 on both sides. And then we're pretty much done. X equals negative 1 plus or minus the square root of 11. Now, I don't know exactly off the top of my head what the square root of 11 is, but I know it's going to be a little bit bigger than 3 because the square root of 9 is 3, right? So logarithms must have positive arguments. This x means that my answer has to be positive. So if this was negative 1 minus the square root of 11, it wouldn't be a positive answer. So I only have one answer, and it's going to be x equals negative 1 plus the square root of 11. And then I could just plug that into my calculator and round it to the nearest decimal place, the nearest 10th place, which comes out to be about 2.3. if you left your answer as this, I would be totally fine with it. I don't like the decimal answer. I like the exact answer anyway. So either one of these is how you finish up number 21.